Today we will understand another topic of flow through pipes, flow through siphon. Let's understand what is a siphon and when do we use it. साइफन एक लॉन्ग बेंट पाइप होती है. जब भी हमें लिक्विड ट्रांसफ़र करना होता है एक रिजर्वायर से दूसरे रिजर्वायर में, जिसके बीच में या तो कोई हील आ रही है या तो फिर कोई हाई लेवल ग्राउंड है, तब जो लॉन्ग बेंट पाइप हम यूज़ करते हैं टू ट्रांसफ़र द लिक्विड फ्रॉम अ रिजर्वायर which is at higher elevation to a reservoir which is at a lower level, and both of these reservoirs are separated by a hill or a high level ground, then that long bent pipe that we are using, that is known as siphon. We can represent it in a diagram like this. We are having two reservoirs as shown here in this diagram. This one is my reservoir A, which is at a higher elevation, and this one is my reservoir B, which is at a lower elevation compared to the reservoir A. And I want to transfer liquid from the reservoir A to reservoir B. Both of these reservoirs are separated by a hill, or we can say a high level ground. In such cases, we use this long bent pipe, which we call it as siphon. We can also use siphon to take out liquid from a tank which is not having any outlet, or to empty a channel which is not provided with any outlet sluice. Here you can see this point, which is the highest point of the siphon, and that we call it as summit, denoted it with the symbol S. Then here the left side of the portion of the siphon, that we call it as the inlet leg. Left side portion of the siphon, we call it as the inlet leg, and this is the right side portion of the siphon, that we call it as the outlet leg. Left side portion inlet leg and right side portion outlet leg. The depth from the summit S to the water level in the reservoir A, that we are denoting it using HA, and the depth from summit S to the water level in the reservoir B, that will denote it with HB. PS is the absolute pressure of water at summit S. Because the summit is above the water level in the reservoir, so the absolute pressure at the summit S will be less than the atmospheric pressure. और ये जो प्रेशर डिफरेंस क्रिएट होगा विच इज़ पी एटमॉस्फेरिक माइनस पी एस, इसी की वजह से साइफन में से लिक्विड फ्लो हो पाएगा. बट एक और चीज़ ज़रूरी है, एंड दैट इज़ ये जो प्रेशर है एब्सोल्यूट प्रेशर ऑफ द वाटर एट द समिट विच इज़ पी एस, ये कभी भी सैचुरेशन प्रेशर ऑफ द लिक्विड से नीचे नहीं जाना चाहिए. और इसकी एक लिमिट होती है दैट आई विल बी टेलिंग यू. बट अगर ये सैचुरेशन प्रेशर से नीचे चला जाता है तो वेपर विल स्टार्ट फॉर्मिंग, एंड बिकॉज ऑफ विच कैविटेशन will start to occur in the siphon, and definitely when cavitation will occur, the flow of water will get obstructed. So it is necessary that the pressure PS should not fall below the saturation pressure of the liquid. Let's see the limit of pressure PS. Theoretically, we can lower this pressure up to minus 10.3 meter of water. This value is possible theoretically, but practically the possible value till which we can lower the pressure PS is minus 7.6 meter of water. And if we write it in terms of water absolute, then it will be 10.3 minus 7.6, which is 2.7 meter of water absolute. If the value at the summit falls below this, then the dissolved air and other gases will come out and it will get collected at the summit and the flow of water will get obstructed. Now we'll be deriving the equation for length of inlet leg. Here I'll just denote it in the diagram. Starting from here to here, this is the length of the inlet leg, which I am denoting it by the symbol L1. In order to find this L1, we'll be applying the Bernoulli's equation from A to S. First of all, let's just denote this datum line in the diagram. Then the datum head, this is ZA. Here it will be ZS. And from the water level in the reservoir B to the datum line, that will be my ZB. Now let's just apply the Bernoulli's equation between A and S. For A, it will be atmospheric pressure, P atmospheric upon rho g plus ZA is equal to PS by rho g plus V square by 2g plus ZS, plus we'll consider the frictional head loss, which I am denoting it using HF1. Then this will become, one more thing is P is equal to rho GH. We already know this. From that we can write that P atmospheric upon rho g will be equal to H atmospheric, and PS by rho g will be equal to HS. That only will substitute in our equations. This is at H atmospheric plus ZA. Here also I'll write this at H atmospheric plus ZA is equal to HS plus V square by 2g plus ZS plus HF1. Then I'll make HF1 as the head of the equation. So HF1 will be equal to H atmospheric minus HS plus ZA minus ZS minus V square by 2g. We already know the equation for head loss due to friction, which is 4FLB square by 2GD. Here in place of HF1, we'll just write that equation, which is 4FL1 V square by 2GD. Firstly, in the diagram, I just want to show you one thing, which is HA is equal to ZS minus ZA. Here it is clearly seen that HA is equal to ZS minus ZA. Instead of ZS minus ZA, we'll be substituting HA. So this will become HATM minus HS minus, I'll take minus common, so that in bracket I'll be left with ZS minus ZA minus V square by 2g. Now I'll just write here 4FL1 V square by 2GD. Diameter of the siphon is capital D and velocity of fluid in the siphon is capital V, is equal to HATM minus HS. This ZS minus ZA is HA, so it will be minus HA minus v square by 2g. Then writing this, making L1 as the head of the equation, L1 will be equal to, we just need to multiply it and divide this, 2gd divided by 4 fv square, 2 2s are 4, so it will be gd upon 2 fv square into hatm minus hs minus ha minus v square by 2g. This is how we'll find the length of the inlet leg. Then we'll apply the Bernoulli's equation to A and B, and that will be P atmospheric by rho g plus ZA is equal to, again for the reservoir B, it will be atmospheric pressure P ATM by rho g plus ZB plus head loss due to friction, which is HF. This will get cancelled and will be left with ZA minus ZB is equal to HF, which is equal to 4 FLV square by 2GD. Here we understood what is siphon, when do we use it, what is the limit till which the pressure at the summit can be lowered. Then we derived the equation for the length of the inlet leg, and also we applied the Bernoulli's equation between A and B. Hope that you have understood. Thank you.